Hello, everyone. I hope I'm audible to all.
Yes, ma'am, you are audible.
All right. Thank you so much. So, good morning, good afternoon, and good evening. I am Dr. Neha Tiwari. I welcome you as a host of ICICT 2022. Dear authors and invited guests, welcome to the technical session 1E. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are well aware, we've been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances post COVID and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you will enjoy 2 days of the knowledgeable and interactive digital sessions. Also, there is a special note for the presenters. You will be given 10 to 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. And I request, while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce you all to the chair of the session, Caterina Moreira. Caterina Moreira, I'm so sorry, I hope I pronounce it clearly, ma'am. Caterina Moreira is a lecturer and a research at the School of Information Systems, Queensland University of Technology. Her research is mainly focused in developing alternative decision support systems that can deal with uncertainty using the mathematical principles of quantum mechanics. The main advantage of these frameworks is that they can accommodate human paradoxical and irrational decisions, which are very useful not only for cognitive systems but also for not decision making systems that deal with human data. She's also interested in the development of new algorithms and methodologies for the application of machine learning algorithms with responsibility by providing the user meaningful explanations about the underlying mechanisms of machine learning predictions. I welcome you, ma'am.
Thank you very much for the kind introduction.
Yeah, and thank you for chairing the session. Now, I would like to start with your consent. Can we start, ma'am, with the papers?
Yep.
All right. So we start with the very first presentation. I would like to have Andries Dyroy Jansen to start with his presentation. Andries Dyroy Jansen will be presenting a paper with the title Discretization and Representation of a Complex Environment for On-Policy Reinforcement Learning for Obstacle Avoidance for Simulated Autonomous Mobile Agents. You're requested to take over the mic and start with the presentation.
Thank you.
Go ahead.
Yes. Thank you. Hello, my name is Andreas, and I'm a PhD student in artificial intelligence at UiT, the Arctic University of Norway. And I'm going to present my paper where I examine approaches to discretize and represent a complex environment for reinforcement learning agents. My PhD topics include reinforcement learning, game theory, and autonomous multi-agent systems, with special interest in logistics, baggage handling, and Industry 4.0 applications. And as we all know, due to current global events, aviation demand has fallen considerably. This means that airlines have been taking major financial hits and massive debt. Because of this, the industry must cut costs and be flexible in their offers. This again means investing in IT, smart systems, and business intelligence. While passenger flights were grounded during the pandemic, demand for cargo capacity increased due to global supply chains and increased amount of goods being shipped worldwide. This led to several bottlenecks, as passenger flights actually are responsible for 50% of total air cargo capacity. Using smart products, sensors, and autonomous systems may be part of the solution to such bottlenecks. Their use could allow for smart and flexible resource allocation in response to shifting demands. However, such autonomous systems require robust rules for safe and efficient operation. How a complex dynamic environment can be broken down into discrete states and be used in a multi-agent reinforcement learning approach will thus be the focus of my presentation. The use of multi-agent systems and reinforcement learning in the industry has been thoroughly documented, and examples include the use of IoT and smart products on the production shop floor for task and resource allocation, smart self-optimizing baggage handling, air traffic flow control, in addition to planning and pathfinding for autonomous vehicles. Common limitations, however, are that these approaches focused on stationary agents or static environments. They also relied on centralized control and extensive upfront data collection and training. Experiments also focused on single agents or a low number of agents and entities. Based on this, I decided to examine a model of multiple autonomous mobile agents in an environment consisting of a large number of obstacles. Control should be decentralized and training should be online with no data collection required in advance. A simulator was created to run experiments with multiple agents and a large number of obstacles, and examine how agents would respond to congestion and limited space. The simulation should consist of a simplified model, while still having some relevancy to real-world applications. Agents were trained online using on-policy reinforcement learning and did not have any information about the randomly generated environment. In each state, the agents could take one of 4 actions: keep going in a straight line, turn left or right, or stop for a set amount of time. The current state was based on the angle and distance to the nearest obstacles, and 2 different discretization approaches were examined. In the first approach, the state was based on the distance and relative angle to the nearest obstacle in range. Distance and angle values were discretized to construct the state space, defined as a 2D matrix with 500 possible states. The angle between the agent's directional vector and obstacle position was discretized in intervals of 15 degrees, and the distance into intervals of 5% of the total sensor range. In the second approach, the state of the agent was defined based on relative angle and the number of obstacles in each interval, instead of discretizing the angles into 25 15-degree intervals. 4 45-degree partitions based on the cardinal directions were manually defined: front, right, rear, and left, as seen in the picture. The current state is simply defined based on the presence of one or more obstacles in each partition as a true or false value. This again was mapped to a one-dimensional state matrix with 16 possible states. In reinforcement learning, we also need a way to estimate the next state of an agent after taking an action. For the first approach, this was found using trigonometry to find the new position and thus distance and angle to the obstacle. For the second approach, the next state was estimated by simply rotating the current state according to the action, turn left or right, or do nothing for the other actions. In practice, this was done by offsetting the index of each partition. As the main task of the agents was to avoid obstacles, the reward function was based on the distance to obstacles. In approach 1, the agent should learn to take actions to maximize the predicted distance to its nearest obstacle. In approach 2, the reward was based on the presence of obstacles in its front partition. If no obstacles were present, a positive reward was given. If one or more obstacles were detected, the agent would get a negative reward corresponding to the number of obstacles. For both approaches, the agents were given a large negative reward if a collision was detected. The simulated environment was made up of randomly generated and distributed obstacles. The simulator was also interactive, in that one could click or to add or remove obstacles by clicking in the simulator window. In addition to the randomly distributed obstacles, a border of obstacle objects was created along the edges of the screen. No hard world border was defined, and if agents wandered off screen, they were repositioned in their original location. Here we see some example screenshots of the simulator, where an agent moves around the obstacles. A trail shows its past movement, and the label shows its current action and the associated reward. Here are some more screenshots of the agents. In the first benchmark, the effect of the obstacle border was examined. The simulator was run 10 times for 10 minutes, and the number of times agents would leave the screen on average was recorded. We see that with the border in place, the agents were less likely to leave the screen. The next benchmark looked at congestion. The number of collisions over time were recorded, and then the environment was shrunk by some factor. In the first test, the environment was reduced to 55% of the original. However, tests showed that the number of collisions on average only went up by 37%. Shrinking the environment to 23% increased collisions by 228%. From the screenshots and benchmarks, you can see that the agents were indeed able to avoid obstacles to some extent. They also responded to the obstacle border and were less likely to leave the screen. We also saw that cutting the available space in half did not double the number of collisions, but further reductions did massively increase the number of collisions. Both discretization approaches showed promise, and they both have advantages and disadvantages. Approach 1 is more descriptive of the state. It only considers the closest obstacle, uses more states, and its next state estimation is more computationally expensive. Approach 2 achieved similar performance with fewer states, and its next state estimation was much faster to run, albeit with less descriptive states. Overall, both approaches required minimal resources and could potentially run on low-power hardware or edge devices. In conclusion, we have seen two methods to simplify and model the state space for autonomous mobile agents. Training was performed online, and no information about the randomly generated environment was given to the agents in advance. Using a tabular, simple approach, agents were able to learn an obstacle avoidance strategy. using high-level actions also made the demonstration and general understanding of the system easier. And using a similar approach when building and configuring reinforcement learning systems for real-world autonomous agents may make simple proof of concepts easier to deploy rapidly. Thank you for your attention.
Thank you so much, Andreas. That was a very valuable and informative presentation from your end. And the best part is that you finished it well on time. So we've got enough time for question and answers. So I would request Katrina to start with the QA session.
So thank you very much, Andreas, for your presentation. I just have a general question. So when I studied long ago multi-agent systems, we had some frameworks to model agents like belief, desire, and intention frameworks. I don't know if have you ever heard of these, or have you thought of applying some of these multi-agent architectures to your work and see how they would develop?
Yeah, so actually this simulator was developed from scratch completely, but to apply the general concepts like the agent, they have some interest. They want to stay as far away from the obstacle as possible, but they also have to share the limited space. So it's with the limited space, it becomes a shared resource they have to balance. And I didn't have time to talk about it in the presentation, but I also considered implementing some kind of negotiation framework for agents so they can share space more efficiently.
So this result that you showed was with the negotiation protocol that you also incorporated?
No, no negotiation was implemented.
Okay, that would be
So
really interesting, actually. Yeah.
Yeah.
I have another question. Yeah. Continue. Sorry.
Yeah, just saying that I mentioned it in my paper that it was planned for future work to implement some form of negotiation, but in this current state, the agents just move randomly.
Yeah, that connects to my next question about the increase of the number of collisions with the reduced number of area. Why do you think the reinforcement learning algorithm was not able to lower the collisions there with that space?
I think also one of the reasons is that the agents weren't able to stop. They just have to keep moving continually. So they had to just find a way to move around each other, even though the space decreased in size.
So yeah, I missed that part, that the condition that they cannot stop. Okay, that makes total sense. Okay, great work, Andreas. Thank you so much. Awesome. Looking forward to see the negotiation parts and the extension of your work.
Thank you.
You are muted, Neha.
Thank you. Yeah. So I don't think there are any more questions. Thanks, Andreas. Thanks, Katrina. With that, I would like to invite the next presenter, Sergey Sullivan. He'll be presenting his views on blockchain for trailer pickup error in maritime ports using Hackathon to prototype potential solutions, the case study. So I'm sure Sergey is all set with his presentation. He's from Denmark.
Yes, hello.
Yeah,
hello, everybody. I hope you're having a lovely day today. Let me just share my screen. I'm sorry, it will take a while because the Zoom got updated.
That's absolutely okay.
Yep. Yeah, they asked me for permissions. 1 second.
Will you be able to start it in a minute, or shall we
Um,
start with the next presenter?
um, yes, I think I will try it now. Okay. Let me try it.
Sure.
Do you see anything?
Yeah, we can see your screen.
Yeah. Okay, good. I
Yeah.
will try to. And now, do you see the whole screen?
Yes. Very
Yes,
much.
perfect. All right.
Yeah.
I'm really happy to tell you about my paper, which is called Blockchain for Trailer Pickup Error in Maritime Ports. So you're gonna hear a bit about trailer security. And we use the hackathon within our project. And our project is called Bling. Bling stands for blockchain and government. So basically it's delivering, exploring, and enabling blockchain services for government or for citizen. The goal of the project is to extend the knowledge about blockchain, about its capabilities, what can be done, and so on. We have 13 partners across Europe, across Northern Europe. So we have partners in Denmark, Sweden, not actually in Norway, Germany, Netherlands, Belgium, and United Kingdom. And if you're interested, you can get more information from the website, which is, the link is at the bottom side of the slide. So the whole thing, the idea was to make a hackathon within the project that we are having. And for those who don't know what the hackathon is, it refers to marathon and hacking simultaneously. So it's an event where small groups of people, from 3 to 5 people, participate and develop from scratch a prototype within a given industry and task, and they have limited amount of time on that. Usually they have 1 to 3 days. And hackathons has emerged recently, maybe 10 years ago, and somehow proved to be a popular way of early stage software development, prototyping, testing ideas, being creative towards some new solutions. And yes, hackathon can be described as a software prototyping, creation of a functional pilot that solves given business case, satisfies customer and stakeholders' needs. Because sometimes some industry companies, they come to and organize hackathons themselves, not just because they want to see some creative ideas or solutions for their needs, but also because sometimes they just want to hire talented people. So in our hackathon, we had 4 tracks, so 4 challenges, 4 different assignments. It was energy, transport, e-voting, and e-document, all related to blockchain. The hackathon, so here you can see the graph of the hackathon timeline. We had 4 tracks. It lasted nearly 2 days, more about 30 hours. We had 137 participants, and we had 8 teams on average per track. So there was a team selection, then challenges were presented to the teams, then teams started hacking, so working on the assignment, during which there was a pre-pitch when they need to present what they have achieved so far. Then we, as challenge owners, so we were, supervising one of the assignment track. We were giving them feedback and then choosing, seeing their results, their final, they needed to present what they have made and choose the final, the best 2 works from there. And yeah, final results and post interviews with the 2 winning teams per each track. And also important thing is that teams and people had mixed knowledge on the maritime industry, because our case is from maritime industry. I will tell you in the next slide. And they also had mixed knowledge on blockchain. Some people know how to deal with blockchain on a technical level, meaning that they can program things. They know the coding language. while some other people, they have limited knowledge, basically being acquainted with the technology for the first time. So because our case is related to maritime industry, so here you can see schematic view on the maritime area. And usually the maritime port can be split into 5 parts. So we have here the ship, which comes to the berth. That's called the place called the berth, where like a parking for the vessel, for the ship. Then it gets unloaded with the cranes, and then some transport helps to. It's called transport area. So the area between the ship unloading or loading to the storage. And here is the big storage yard where containers, and here are the trailers being parked for later pickup by the trucks, which they go through the gate. And the thing is that cargo security is the problem when a freight driver who comes to pick up the trailer takes sometimes not the trailer that intends to take it the first. I mean that the driver comes to the port and claims to take a certain cargo unit at the gates, for example, a trailer, but takes another one instead. When he takes another trailer, the port gate fails, the security of the port gate fails to recognize if he takes the intended trailer. Because sometimes there are no cameras on the gates, sometimes everything is done manually, or the cameras fail to recognize the trailer or the license plate of the trailer because of the dirt. So, and such uncertainty and lack of monitoring constantly affecting the port reputation, confusion in the terminal. So the whole storage yard is not optimized. It's becoming kind of a mess in this case. So we gave this problem to teams and proposed them to prototype possible solution for the trailer security problem, how they can solve it using a blockchain. And there was 3 main indicators. So how they can solve the problem with trailer inventory insecurity, how they can achieve a cross-check of drivers who come to the port, take the trailer and come back. So if we can check if everything matches what drivers are, claiming to take, and how it can contribute to environmental issues by reducing queuing of trucks in front of the terminal, and reducing and minimizing their movements within the storage yard. That was the 3 main indicators. So we gave the task to the teams with in Notion. So there was a case description over here, and we gave more information, like what's the port area is, what are the main stakeholders, how the container can be identified, how the trailer can be identified, what's the document flow in maritime industry, some terminology, gave them some inspiration. And the whole thing was curated in Discord. So we were constantly helping teams and answering their question throughout the whole hackathon session. The results. So 8 teams were on our hackathon track. 6 of them presented their ideas, and here you can see an overview. So six teams gave presentations after 30 hours, explaining their ideas, how they can use blockchain to solve such a specific problem that really exists in one of the Danish maritime ports. And what they have come up with is the partially reimagining the port gate monitoring system. So some of the teams proposed remote identification of trucks by scanning license plate numbers, which already exists partially, but the problems arise when I already mentioned that the cameras fail to recognize the plates due to dirt on these plates. Some teams propose to you the usage of QR codes. So when the freight company and the terminal use one database and share some sort of a record for each trailer that needs to be picked up, and they create a transaction in a system that is attached to the driver and attached to the cargo that he takes, and then he can show a QR code at the gate, which proves that he is actually the real driver that needs to pick up the cargo, which still leaves the room for mistake, because there is no way of ensuring that the driver still can take another trailer, which happens. And it mainly happens because the drivers who come to the port, they have a list of trailers. It's basically like 20, 30 trailers on the list, has to be picked up by his company or the company he's representing. And instead of looking for the trailer, because the space, the whole storage yard is very big, he's maybe sometimes too lazy to go around and look for the trailer because he doesn't know the exact location. So instead, he just takes the one that is from the list that should be picked up by his colleague, and that the whole thing creates.
Just wrap it up in a minute or two.
Okay.
Thank you.
Yes, I'm almost finished. So some other teams also proposed RFID chips, which could be combined with the hardware solution. When the truck goes in, the RFID chip will indicate that the cargo is near, so they can be easily navigated, and at the gate, if there is a proper monitoring system, they can scan and get out at the same time, which an interesting solution. And also automated pick-up area to design a separated space where it will be the pickup procedure would be served the same way as we go to supermarket to get our things from the Amazon, for example, stuff like that. And so here is also a bit of an overview, so we don't have much time for that, but it's just a graphical representation. So most of the teams, so here's the legend, Hackathon challenge, gate monitoring, and they wanted to attach the blockchain to their solutions. So we have some RFID chips, self-sovereign and identity, hardware solution. So some of them would be combined with the hardware solution, and the table with the summary. So for conclusion, I would say that was interesting to give a hackathon for people with mixed knowledge. Unfortunately, we think that 30 hours was not enough for the teams to come up with a tangible solution, something that would be more than just a bit of a prototype. It could be maybe coded or having some user interface. Yeah, so basically time limits were the drawback, and the various backgrounds yeah, people had spread knowledge on the topic. So things like that. That was the idea of the paper. Thank you. I will love to answer your questions.
Thank you so much, Sergey. I hope that this case study would help many who are performing their research in this similar domain. I request Katerina to come up with her queries.
Thank you, Sergey, for this work. It's very different from what we see usually in these very technical conferences. So I'm very interested that you engaged in these case studies and in these events with people. I will say that I'm not an expert in blockchain. So the questions that I will ask will be about more related with what do you think that throughout this process during the hackathon, what you think could be improved in order to be able to provide more interesting solutions, or even provide, I don't know what was actually your, what you were actually looking for in this hackathon. Was it focusing on the learning experience? Was it actually focusing on the prototypes that they were developing? Can you tell me a little bit more about this process? What can be improved for future research as well? I speak
Very,
too much,
very
sorry.
interesting question. I was expecting a bit. Yes, there were two main points for the hackathon. The first thing was to see exactly what they would propose, just because what the beauty of hackathon is, because people come up with something completely new, and people from the industry, they sometimes have this kind of old-fashioned, viewpoint. They're not aware of new technologies and so on. And at the same time, we wanted to see how is it can be considered from the teaching, point of view for the teams. But solutions were the main point. As for the how we can improve hackathons, I think hackathon is a relatively new thing, and it's very different. So it has a lot of limitations due to the format itself. But that's the beauty also of it, because the teams are concentrated on the task within, I don't know, 40, 30 hours, just on the task, so they don't have any other distractions, let's say, at the same time. So that's very interesting, because within 1-2 days, people from zero knowledge can get to some kind of a intermediate. That I think it's really good.
How do you think from this work it can be extended for your future research? What can you take here as directions as an overall? So this is part of a research work that you are doing as well, right? So what learning that you take from here to expand or direct your research?
Yep.
I'm more interested in understanding your research point from here.
So my research is mainly about possibilities of blockchain for maritime industry, and I try to scale down to maritime port, and I had found some scenarios of how it can be applied in the maritime industry, but I would like to scale it a bit down for the maritime port in particular, because maritime port is a very small part of the whole supply chain. So it's just a kind of a small dot throughout the whole thing, and it just gave me some ideas how I can develop and make more research about. So
I think it's a fantastic exercise. Even I think that in terms of PhD students, I think this should be something that people should invest, because it enables some brainstorming from an audience that is not really trained as a pure researcher. So it doesn't have the views so narrow. So I think this is a wonderful idea, and continue to expand it. I think you will get fantastic ideas from the public, and the brainstorming is what actually you take as gold from here. So congrats.
Thank you very much. I will.
Cheers.
Thank you very much.
Cheers.
Thanks a lot both. That was really very interactive. In fact, I think many of us will get benefited out of it. We'll also get some new ideas, I would say, for students. With that, I call the next presenter, Avalu Ishaku Liti. I hope I've pronounced it correctly. He's from Republic of Niger. The paper title is E-Government Hybrid Cloud Deployment Architecture for the Nigerian Diplomatic Service. I request you to start with your presentation, and please stick to the time limit, which is 10 minutes, 10 to 12 minutes. Try to wrap it up after 10 minutes. I'll give you a reminder. You can start now.
Okay. Thank you very much. I'm just trying to share my screen to get the presentation up, but okay, I think it's.
Please start with your screen share.
Okay.
Yeah, that's visible.
Okay, so good afternoon, everyone. My name is.
Please start with the slide presentation.
Yes.
Start with this show, please. Yeah. Thank you.
Yes, I have. I've shared my screen. You can see the slides. I believe everybody can see the slides.
Yeah, we can. You just have to start the slideshow.
Okay.
In full screen mode. Yeah.
Start with the full screen view.
Yeah. Yeah. Okay. So Good afternoon, everyone. My name is Awali Shafaliti. This is a paper we worked on with my other colleagues, Zainab Ibrahim from Yonsei University, South Korea, and Wazir Azentia from Coventry University in the UK. The title is E-Government Hybrid Cloud Deployment Architecture for the Nigerian Diplomatic Service.
The slideshow button is right, like there at the right-hand side of the lower side of your screen. That is the status bar. Just click on that, or you can use the shortcut key.
Yes. Can I go on?
Yeah.
Hello?
Yes, you can.
Anyway,
Let's start with the slideshow. Yeah.
The idea behind this paper is we realized that organizations are continuously embracing cloud computing technologies to deliver several services to the users. And why this increased interest in cloud computing technology is due to the underlying benefits of cloud computing technology.
Yeah, I don't think the screen, like the slideshow, is visible to us. It's not in the full screen mode.
Well,
Katrina, I don't think it's in the full screen mode.
No, it is
well,
not. We don't see you changing slides.
Right. Avalu, just go to the slideshow menu.
Yes, I am on slideshow at the moment.
No, it's not in the full screen mode. I'm so sorry. The slides are not even getting changed. So, yeah.
You can try to select each slide manually if that exactly, yes, that helps. It's fine, yeah.
Is it in the slideshow mode now? Because it is on slideshow mode from my access here.
We don't see it in slideshow, but it changed slide at least, so you can continue. Yeah.
Okay. So, like I mentioned earlier, it's part of the reasons why we believe organizations are increasingly embracing cloud computing technologies is because of some of its benefits, which are in form of the cost efficiency, ease of scalability, and its availability. Over time, we have seen governments are embracing same cloud computing technologies to deliver much needed services to citizens. And of course, that brings the e-government aspect of it. Now, the diplomatic service actually makes an ideal case for an organization that would use cloud computing technologies because of its availability in different zones and its global penetration. So in everything that we did with the methodology and everything, we actually developed a hybrid cloud computing architecture for using the Nigerian diplomatic case study. We used the open group architecture framework as and for the theoretical underpinnings for our development. And at the end of the day, what we did was the hybrid cloud architecture consists of a community cloud, a public cloud to actually deliver these services. Looking at the origin of cloud technology, two isolated events, the DAPA Defense Advanced Research Project Agency with the Project MARC, as well as the ARPANET, the Intergalactic Computer Project Network, which with the Project MARC required simultaneous use of a single computer by 2 or more people, as well as the Intergalactic Computer Network Project use the computer network project sought to ensure global interconnectedness by different computers in diverse locations. Now, there's equally the advent of virtualization, which virtual machines are used to have a functional for compute as well as for functional operating systems. So also the advent of the internet gave rise to the deployment of virtual private networks. And of course, eventually that gave rise to rented services. In terms of definition, there are several definitions of cloud computing. We decided to, of course, there are three major definitions. We can look at the IEEE definition, the National Institute for Standards and Technology, NIST, and then the Berkeley R&D Lab. I may not need to bother you much with those definitions. They are standard definitions and can be looked up anytime. With the categorization of the cloud computing models, we actually looked at the service model as well as the deployment. With the service model, we have the SaaS, which is as a service. We have the platform as a service.
Letty, sorry to interrupt. We are not seeing your slide. I believe you are in slide number 4, so you could click it manually there so we could see it.
Okay.
Because we are still in the introduction slide.
Can you see it now?
Not yet. Can you try to really manually click on the, or at least leave full screen mode and manually go to the slide number 4?
Okay. Select your slide number 4 directly.
Are you having more than one screen at the moment? You have two monitors, two computer monitors, because that can also.
Okay, I have only one at the moment.
Okay.
Yeah.
But we still cannot see the change of slide. We are still in the introduction.
Oh, no. Well, okay.
You can do one thing.
The thing in computer science is that the things work by restarting things.
Is this?
Right.
Let's see. Okay, perfect. We are seeing the cloud computing. Yes, we are seeing the cloud computing.
Okay. Okay, so we looked at, can I go on?
Yes, yes, of course.
Okay, thank you.
Now you're in the introduction.
We looked at yes.
Okay.
We looked at the service model, which consists of software as a service, platform as a service, as well as infrastructure as a service. And the deployment model actually consists of private cloud, the public cloud, as well as the hybrid cloud. And then, of course, we have the community cloud. So e-government. E-government actually has several definitions, but for the purpose of this paper, we can just take a simple definition: the use of information and communication technologies to improve the activities of public sector organizations. This definition sometimes can be viewed as restrictive, but it does actually serve the purpose for this paper. We looked at the offerings of cloud computing to e-government. It offers the ability to give services, scalable services, efficient services to users using the different types of e-government users. That's government to government, government to business, as well as government to citizen. The benefits include the scalability it offers, unlimited storage, backup and recovery, cost saving, green technology, availability, as well as accessibility. This is not exhaustive, but it's just a few of the benefits. There are several examples, like we mentioned earlier, that governments are increasingly embracing the offerings of cloud computing technology. And there are several examples in the UK, Saudi Arabia, Kuwait, Australia, and a lot of other governments are continuously embracing cloud computing technologies. Still on the benefits, these are just a few benefits that cloud computing technologies offer with the implementation. Of course, it gives most organizations leverage on the virtualization of organizational IT resources. And then this gives the potentials of increased organizational value through efficient sharing of information. Of course, there's efficiency that it gives. And then successes are usually recorded in forms of increased business values, and then economic values, and of course, extension of services, the service delivery. So looking at the diplomatic service, usually it's just a body of diplomats or foreign policy officers that usually are maintained by the government of a country to communicate with other governments of other countries. There are several services. We try to actually look at the different services that are being offered by different diplomatic organizations. And some of these services are in terms of copy of birth, death, or marriage certificates, legalization of documents, affirmation of marriage, help with arrest abroad, emergency travel documents, passports, visas, citizen services, as well as this list is not completely exhaustive. There are a lot of other services that are being offered by different diplomatic services. But this with regards to the Nigerian diplomatic service, these are some of the key services that are being offered. And the idea is these services should be available globally, and the citizens of that country, as well as other people that use those services from other countries, can access them seamlessly. So the methodology we used, like we mentioned earlier, we used the Open Group Architecture Framework and as the theoretical underpinning. And the TOGAF is a requirement-centric framework that is developed as a standard method for enterprise architecture design, which inculcates enterprise information, infrastructure elements, technology services, and processes. And TOGAF employs usually an iterative process to model and optimize enterprise architecture design while mitigating risk. The other one is architecture development model, and it's used to provide solutions that entails numerous stages of transforming and governing established architecture solutions against recognized architecture. So what we did is the methodology, identification and establishment of service offerings and information needs of the Nigerian diplomatic service, then identification and development of the architectural requirements by finding the optimal interrelationship between both, the different aspects with the IT as well as the business cases we have. Then of course, categorize them into different, we align them with the offerings of available cloud computing resources, while at the same time, we try to factor in issues of security and confidentiality. So, and then we looked at maybe a phased deployment.
I request you to sum it up in last 2 minutes.
Sorry?
Kindly sum it up in 2 minutes.
Oh, okay.
You just have 2 minutes. Yeah.
Oh, okay. So effectively, what we have, we created, we have a community cloud computing architecture where we have the different embassies coming together with shared information, shared services, and we created a cloud, a community cloud, which is situated in a specific, in a given available zone. And what we did is we used AWS, the Amazon Web Services, to actually, we proposed the use of AWS. And as we know, AWS has different availability zones. And then we use a public cloud to interconnect the different community clouds that are in those availability zones to the different area. And we have a diplomatic-wide cloud computing architecture. In terms of the services, the model, we used for compute services, it's to be provided by EC2, which acts as a virtual machine for both the web server as well as the application server. Then the virtual machines also have their individual storages in form of EBS, the elastic block storage. And then to ensure scalability and efficiency, a load balancer in form of elastic load balancer, ELB, specifically network load balancer, NLB, is connected. And then we have virtual machines that are linked to, the virtual machines are actually linked to a relational database in form of the Amazon RDS relational database.
I think he lost the connection.
Yes.
Yeah. So shall we wait for him to join in a minute?
We can wait
I think we
just, or we can move on, and then I can, when the other presenter finishes, I could return to his presentation to ask questions, and then focus on the next presenter.
Yeah. So can I call the next presenter? Yeah, I think he lost the connection totally. Yeah. Okay, so we'll get back to him the moment he joins after the next paper presenter finishes his presentation. So I call Mohammed BM Kamil from Germany. He's going to present his views on D3VN, decentralized ABE-based distributed data validation network. So that seems to be quite an interesting topic. Over to you, Mohammed Kamil. I'm sure you're there. Yeah, I can see him. Yeah, we can see the presentation, but we can't hear you.
Can you hear me now?
Yeah, I can hear you now.
Okay.
Right. Yeah.
Perfect. Okay, good afternoon. I am Mohammed, and I'm from Florida University, Alta, and Fort Wayne University, and my talk is about D3VN, decentralized ABE-based model for the data validation network. I will start with a bit of introduction about the data validation network itself, then problem statement and the motivation, and then some primitive backgrounds that we have used in our model, then the proposed model and analysis, and finally the conclusion. Distributed environments such as, for example, the IoT network, they consist of many connected devices, and those devices generates a massive amount of data. So these generated data received by the clients, and then based on those data, then some decision makings and some smart decisions are made. And then it's really crucial for these data to be validated before consuming them directly from the data consumers, and considering some of the data sources that are like publicly available. So those data should be validated. To avoid the dependency on a single validation component, and then to prevent single point of failure during this data validation, the data validation network that consists of several distributed nodes can be used. So the question comes that why data validation network? Why not validating the data in a single entity? Firstly, not all generated data by the resources will be used by the clients. Therefore, processing only consumed data by the clients considered more efficient than processing all of the data that with high probability we won't use all these generated data. Then handling the generated data locally, let's say on some nodes, for example, the gateways caused loss of the generality. And then instead of processing the data locally, in that case, we won't take into consideration other generated data in the same region. And finally, there are a lot of unused computation powers. For example, machines, production PCs, tablets in a shop floor, etc., etc. And those can be used for the data validation instead of being idle. So the research question is that how the data validation network can be created that works in a random approach. It's really important, based on verified attributes. So it's the second requirement of the data validators, and then without involving any trusted third party. So we have used two technologies or two primitives that I will quickly mention. One is the attribute-based encryption that consists of those 5 players, 3 sets actually, and one is the attribute authorities. So each organization can have its own attribute authority that generate public keys to be used for the encryption and generate private keys to be used by the decryptor. Most important feature here is that this works in a one-to-many instead of like compared to the normal one-to-one scheme. One encryptor can encrypt the data and send that to many decryptors based on their attributes. Another primitive is the LADA, the locality aware distributed addressing that we recently published. And this overlay is a location-based overlay compared to the other models. Unlike alternative solutions, no predefined list of known landmarks are required in LADA, and it has a significant improvement compared to during the creation of the overlay. So this will be a logical overlay on top of the physical underlay network. Then our model, the proposed model, consists of 5 sets of participants, a set of objects that are entities in the system that handle one or more data sources. For example, a temperature sensor. So those are the data sources that produce the data in the network. Then on the other hand, the set of clients represent the members that consume the data that are produced by the data sources in the system. Then one or more objects are connected to a gateway. So the relationship here is one to many. And then we have the attribute authorities. An attribute authority is a set of, is an entity that manage one or more attribute, and it generates set of public and private keys for them. So the public keys will be used by the gateways and the private keys will be sent to the data validators. And then we have the data validators. So those are the mostly idle nodes, for example, a computer on the shop floor, and those can be used for the data validation. And we assume the participants are distributed in the system and there is no centralized trusted entity. Then in terms of the logical clusters here, we have used modified version of LADA overlay, and then logically position the data validators in various overlays, and those overlays are here the clusters. So the data validators, a physical data validator, can be part of various region sets or various clusters based on their attributes. And when I'm talking about the attributes, they can be like their operating systems, their physical locations, and so on. So they will be positioned somewhere on various clusters. And in setup time, the data validators, they generate the identifiers, they join the relevant clusters, and most importantly, they get the secret keys from the attribute authorities. On the other hand, the resources is first discovered, and then the data from the discovered resources transferred from the data producer through the connected gateway to the data consumer. Then the data consumer randomly selects some elements from the set of some members from the data validators and send the list to the transmitted gateway. Then the transmitted gateway send the data to the list of selected elements, those data validators, and to the client itself directly. Then the chosen data validators perform the validation process, and these validation process might be based on various methods. For example, thresholding can be used, or some machine learning algorithms can be used. And then the result sent to the client, and the client accepts the result if it could verify the attributes of the data validators. Then there are two security properties required for the D3VN that we proved in the paper, and I will only mention them here. Is that in terms of completeness, every validator with attributes that satisfy the defined access policy can validate the data. And in terms of unforgeability, every probabilistic polynomial time validator without attributes that satisfy the defined access policy by the relevant client can access the data with negligible probability, and this access policy is defined during the encryption. As a conclusion, so the use of a centralized instance is no longer necessary in our model. Therefore, there is no single point of failure during the identifier generation, during the selection of validators, and various steps of our model. And a validator can generate an identifier per cluster without centralized entity. So these all result in a performance gain as long as the ratio of the identifiers is less than the ratio of the client choosing the validators. And then the generated identity of validator can be verified. And in terms of future directions of this research can include more complex formula for the data validation selection or for various steps. And then the different validation capabilities, because our assumption is that a single validation capability, and other involving other validation techniques, for example, thresholds or machine learnings during the validation process. Thank you so much for your attention, and if there is any question.
Yeah, certainly. Katrina would take over now.
Thank you very much, Mohammed. Actually, I found your talk very well structured and very clear and objective. So every time I would think about a question, you would answer it in the next slide. So very good on that. I just have a few questions because, again, maybe it's because I don't understand much about how these distributed architectures work, but I was wondering why this importance on the random selection data for the validation? Why is it, why random?
What is important? Why random? Yeah, because the assumption is that, yes, it's a very good question. Because the assumption is that these are the data validators that we mostly do not trust, and we wanted to create this trust. For example, I am like, I want to use some data and I want to validate this data, but so the nodes that I will choose as a client to validate this data, those are the nodes that I do not trust. So I want to create this trust by randomly select the data validators from various clusters. and then take the decision based on the results. So we have, let's say, probability calculation in other paper that with high probability, a single, let's say, malicious entity cannot send us, let's say, cannot affect the final result. So the short answer is that those data validators are some pieces that we might not trust.
So maybe this question is a little bit out of scope, but I'm just curious. So when you have a connected network of sensors and each sensor is detecting its own features, I was wondering, so for decision making, what happens if one sensor disagrees with another? Let's say that I want to decide on crops and they need to grow, and one sensor says you need to put more water, the other one says you do not put more water. How do you approach, how do you validate this conflict between sensors in your framework? Maybe it's out of context, but I'm just curious.
No, it's really great question. So first of all, usually there are like number of sensors. So usually there are not only two, there are like more sensors in one geographical place, and each of those sensors. So the probability of all being corrupted or I don't know have some problems, this is really negligible. And because of that, actually, it's really important to not doing the data validation on the nodes themselves or the directly connected gateways, because that will lose the generality. Then the client in this case, for example, we have like a humidity or water sensor. In this case, we won't take during the data validation, we won't take only into consideration those let's say sensors, but all sensors in the given geographical area. And based on that, the decision will make that let's say what is the right data. I will give you, for example, an example is that, for example, if it is rainy, then we have like a light sensor. Then if we have another sensor that defines a specific reading for the humidity, we can somehow, based on some thresholds, let's say, be sure that which of these nodes are the right nodes. Because, for example, it's rainy, there is no light, so with high probability, there will be specific, let's say, a range for the humidity right now. And this all comes by validating the data in the data validation network and not locally.
Okay, makes sense. Thank you so much, Mohammed, for the explanation.
Thank you.
Very clear explanations. Thank you.
Thank you.
Indeed. So I can see Awalu has joined back, but can we get back to him after the rest of presentations are over, if you permit, Katrina? Yeah, that would be better.
Yeah.
All right. Okay. So now I call Nermin M. Salim. She's from
Good afternoon. Let me share my presentation.
Egypt. She's gonna present her views on. Come again? Yeah, you can. Yep. So she's gonna speak on.
I can share screen. Can you open the option?
All right. I was just about to read your paper title. That's ANN model for two-way shear capacity of reinforced concrete slabs without shear reinforcements. Yeah. Now you can start with the presentation. Thank you.
Okay.
I request you to stick to the time limit.
Good afternoon, ladies and gentlemen. Today I will present the work done in the research paper called ANN model for two-way shear capacity of reinforced concrete slabs without shear reinforcement. This study was conducted by myself, Dr. Nermin Salim, and Professor Ahmed Defalla from Future University in Egypt. Our agenda for today: first, I will start by talking about the background of this topic, then problem statement and the motivation to perform this work. Afterwards, I will talk about the research significance and scope, and scope of our work. Then I will talk about the artificial neural network model development and the validation methods we use to measure our results, and the conducted parametric study, and finally our conclusions and references. Bunching shear behavior is a complex problem which involves several parameters and it is governed by several mechanisms. Fiber reinforcement polymer FRP is a mainly new material that is a feasible replacement for conventional steel reinforcement. Bunching shear failure happens due to the column punching the slab having a complete failure of the slab, sudden, brittle, causing catastrophic damage in the building. The phenomena is governed by so many parameters, including the flexural reinforcement as the dual action component, and also the aggregate interlock, and the interface shear across the diagonal crack, and finally the direct shear at the compression zone. So these three components, dual action, flexural shear reinforcement, the resistance of the bars, the reinforcement of the aggregate uh, interlock, the interface between the crack sides of any diagonal crack, and finally the direct shear across the compression area. Crack width is considered to be a very important component that govern almost related to all these components. Cracking pattern for such a failure, which is a very complicated pattern, and the theory behind it is not yet developed. Punching shear failures are brittle and punching shear modeling is in need of further investigation. Available model lacks the accuracy and consistency needed for accurate, safe design. Artificial intelligence models have found to be reliable, consistent, and accurate for predicting the strength of element in many applications. Many failure has happened due to punching shear failure, such as parking garage during earthquake, as shown in figure A, B, and C, and also in Spain in 2020. A parking lot has fell down suddenly in a playground. Luckily, no one was hurt, but this is a catastrophic event that happened in 2020. In our research, we considered the bunching shear as it is still a dilemma, and many investigations are tackling this area all over the world. Very limited number of investigations have talked about using artificial neural network or machine learning model in the prediction of punching shear capacity. These studies have implemented using a small data set which affects the accuracy of their models. In our current study, we worked on a larger database which increased our model accuracy for prediction. We conducted an artificial neural network model and also conducted a parametric study for better understanding of the behavior of different inputs on the prediction of the output shear. The critical point for ANN model is to find the best fit model or the selection of the best training methodology that can give us the best best accurate predictions. It can be considered as an optimization problem where we want to find the most accurate prediction, lowest memory usage, and faster conversions for the trained model. To train an artificial neural network model, we have 4 training methodologies: gradient descent, cosine Newton, Levenberg, Mardet, and conjugate gradient. The chance lie, as I said before, in the choosing the suitable training methodology. We worked with artificial neural network gradient descent model as it show accurate promising results, but we added 2 features. We used an adaptive learning rate and added a momentum term. The gradient descent aim is to find the local minimum of a differentiable function, which means we want to find the coefficients that minimize the error function as much as possible. As I said, We use the gradient descent model with two main modifications, which are adaptive learning rate, and we added a momentum term. Learning rate is considered to be a very important hyperparameter in the ANN training phase, as it controls the changes in the model, which means we control how quickly the model adapts to a given problem with respect to the measured error. It could be considered as the most important hyperparameter. uh, Choosing a too large learning rate may lead to a quickly convergence, which may lead to finding a suboptimal solution and not the optimal solution we want to happen. Also, choosing a too small value, it may lead to an unstable training, and we don't want we want our model to be stable. For our model, we used the default value of learning rate equal to 0.01, and this value is updated at the end of each training epoch based on the training performance. If the training performance decreased, this means that we need to increase the learning rate by a factor equals to 1.05. Otherwise, it is decreased by a factor equal to 0.7. The advantage of using an adaptive learning rate that it leads to more faster and stable convergence. Also, we add a momentum term which help in the increasing of the convergence speed. It is computed The momentum term is computed from equation number 2 as a derivative of the performance. The training methodology of our ANN gradient descent model could be shown from this figure. First, we divide the data set into three main parts: training with 70% of the total data, then validate with 15%, and finally testing with the last 15%. Initially, the weights of the artificial neural network are randomly assigned, and during the training phase, they are recomputed using the comparison between the predicted and the actual values, and these weights are updated and then they back propagated through the network. And the training continues until either one of the stopping criteria occurs. Either it reaches the maximum training epochs predefined, which is predefined, or converges to the optimal solution. Our model was trained with 5 inputs: column dimension, effective depth, concrete compressive capacity, flexural reinforcement ratio, and finally Young modulus. The output of our model is the prediction of the two-way shear capacity of FRB. The model architecture could be shown in figure 2. We have one layer composed of 5 neurons, as we have 5 inputs. Then we have one hidden layer composed of 11 layers, and one output layer to output our two-way shear capacity prediction. Our model was trained by using a dataset composed of 189 records. In table 1, it shows a summarization of the ANN model training. As I said, we used 5 neurons in the input layer, one for the output layer. The hidden layer activation function is sigmoid, and the output layer activation function is linear. The error is computed based on mean square error. To evaluate the effectiveness of our proposed model, the following statistical measures are calculated for our proposed model versus recent state of the art. We reported the average value, root mean square error, coefficient of variation, and finally the lower limit based on one-sided 85 confidence level. Our model outperforms other state-of-the-art which work for the same prediction problem. Our model had an average value equal to 0.97, coefficient of variation 20%, root mean square error equal 1 and lower 95% equal to 0.93. Also, a parametric study was conducted from our model. It showed that the fluctual reinforcement ratio was found to have a small effect on the strength, which could be attributed to the significant reduction in the transversal resistance of FRB reinforcement, which leads to diminishing the dual action component. Our conclusions that we developed an ANN model and implementing a parametric study. The model was found, our model was found to be more accurate, consistent, compared to selected models. We also conducted a parametric study to show the effect of various parameters. From the parametric study, we noticed that the fluctual reinforcement ratio was found to have small effect on the capacity, and also the effect of concrete compressive capacity was found to be different than the traditional variations, and the effect of the size and concrete compressive capacity was found to be dominant on the capacity prediction. Thank you.
I would request Katerina to take over.
Thank you, Nermin, for this presentation. Yeah, I have I think I didn't catch it in your presentation. So after all, which method did your model use? Quasi-Newton, the best model, which one?
Gradient descent with two.
Gradient descent was still the best. Okay, that's interesting to know, because usually these methods, you know, they have this trade-off between memory in computational, which translates into speed, right? Although gradient descent in its simplicity usually is slower, but has the advantage of requiring less memory compared to the other algorithms. So this is quite interesting. Actually, from your presentation, I was trying to see if what was the name? I think it's the number third, the quasi-Newton, probably. I thought that would give better results. Could you expand a little bit on what you found as advantages and disadvantages in your experiments of all other methods that you applied in your neural network? I think.
Nermin, are you there?
Could you repeat the question?
She's there. Sorry. Yeah. So I was wondering yeah. So if you could discuss during your experiments, if you could discuss on the advantages and limitations that you found that these methods that you tested, the Levenberg algorithm, the quasi-Newton method, where did you feel there could be advantages or disadvantages in your project?
The main advantage
why do you think they didn't perform well on your problem that you were doing?
Mainly choosing the suitable training algorithm based on the database I have been working with. Some may give very good result in another database, while wouldn't give the same good result with my database. So it's mainly dependent on the size and the quality of the information in the database. So when I started training, I performed more than an experiment to select the best optimum solution, not just in training but also in testing, because there was some methods that was give high values for training, and when I test with the testing set, it performed very poorly, which didn't give actual prediction for the punching shear capacity. So the trade-off was to find a model that perform both in training and testing, and not just in training only.
Thank you very much, Nermin. That was clear. Thank you.
Thank you.
Okay, so with that, we move to the last presentation for this session. I would like to ask Kimasha Bora, she's from India, to start with the presentation on the paper titled Symptom Network Analysis of Social and Mental Health Complications of Alcohol Use Disorder. Kimasha, you can start with your screen presentation.
Okay, thank you, ma'am. एक मिनट होगा। Whether you can see my slide.
Whether you can see my slide?
Is it visible?
Is it visible?
Now we
Yeah,
can,
you
yes.
can see it. Yeah, it's visible. Please start with the screen like presentation. Full screen. Yeah, we can see it. Yeah.
Okay. Respected chairperson and delegates, today I'll be presenting the result of my research work. The title of my paper is Symptom Network Analysis of Social and Mental Health Complications of Alcohol Use Disorder.
Yeah, Kimasha, you're audible enough.
So alcohol consumption has numerous health and social consequences and is regarded as an important contributor to death and disability. Approximately 2.3 billion people are current drinker. Death and daily adjustable life year due to alcohol is higher than attributable to diseases such as diabetes, TB, HIV, etc. So the genesis of most alcohol use disorder rests with a complex interaction between biological, psychological, and social factors. And alcohol use disorder are often known to cause physical, mental, social, financial, and familial harms. And the level of harms are associated with the level of use, pattern of use, financial problems, familial problems, individual and social problems. So thus making it a potential ground for application of network theory with numerous hubs. Next to can I get the book? So the current studies aim at to explore the relationship between the frequency of drinking and related health problems.
Please move to the next slide, Kimasha. You're still on the introduction slide.
Maybe you can try to turn off PowerPoint and turn on again. Seems to be helping.
Okay, I will try.
Or you can use the arrows there.
Okay, so the current study is the aim of to explore the relationship between frequency of drinking and related health problems attributable to alcohol use among the network analysis as a tool to define the connectedness. So a place of our study is the Dibrugarh, Assam, India, and sample was collected from the patients attending Drug De-Addiction Center of Assam Medical College and Hospital, Dibrugarh. So we consider only hospitalized cases aged 18 years and above, and both sexes will prefer. And the cases with alcohol use disorder diagnosed by consultant psychiatrist of Assam Medical College were included in my study. And critically ill patients and patients refusing to participate in the study were excluded from our study. So we use different tools for our research work, a specially designed questionnaire to collect the data. And the questionnaire includes the questions related to the pattern of drinking and also the questions related to the social harms and psychological harms. A structured proforma for socio-demographic variable. A software tool we are using is the Gephi software. Gephi is an open source network analyzing and visualizing software written in Java platform. So this is the summary of our method. The patients diagnosed with alcohol use disorder by the consultant psychiatrist. We can fulfill the application of inclusion and exclusion criteria. Then we take in consent and requited for the study and then administer the questionnaire. And after the data will be analyzed. So first we enter the data in our Excel, and after the data will be analyzed by using a Gephi software. And two separate graphs were created from the data set derived from the structure tool, and the grouping been done based on the area of inquiry, that social correlates of alcohol use and psychological consequences of alcohol use among the study participants. Frosterman and Reingold layout algorithm was used for the analyzing. graph. This is the symptom network of alcohol and social difficulties. And where you observe my graph, where there are some nodes which are regular once or twice per week, 3 to 4 days a week. These are the cluster of the pattern of drinking. This is the important factor to find out how harms in the socially or mentally they are influenced by the pattern of drinking or the level of drinking. So we clustered it into different groups, regular once or twice per week, 3 to 4 days per week, and they are associated with, and we try to show the connection of a pattern of drinking with different social consequences like irregular at job, financial problems, decreased work performance, fights with family, dependence, arguments with colleagues, financial dependence. And if we observe my network, the regular pattern of drinking is more strongly connected with different social problems like decreased work performance, arguments with neighbors, fights with family, loss of family support, loss of reputation, etc. So the statistics of my graph is like that. The network diameter is 5, graph density is 0.157, average weighted degree is 10.24, and average path length of edges is 2.12. So if we observe my graph, the higher the degree of the nodes, obviously the more connectivity means the degree is higher. So regular is the highest degree among all the other nodes in my graph or in my network. So the most important factor is the frequency of drinking, and the second, common social difficulties like fights with family and decreased work performance. So other centrality measured will also observe, and the centrality, closeness centrality defines the importance of a node in a graph being measured by how close it is to all other nodes in the graph. And regular use has the highest closeness centrality, and among the social difficulties, the observed and the measure nodes are like arguments with neighbors, irregulars at job, decreased work performance have the same closeness centrality. After observing the harmonic centrality, it was found that frequency of drinking behavior is more influential than any other factor among my graph and all the other nodes. Frequency of drinking is more powerful than any other nodes. So obviously, if we remove the drinking pattern from my network, then obviously it will affect the whole network or the setup of my network. So the next centrality measure is the eigenvector centrality. It indicates how influential a particular variable affecting the overall functional outcome of the network node interaction. So here also we found the same output. The frequency of drinking behavior is central to over all expressions of social difficulties. And the other important nodes are like arguments with neighbors and irregularity at job performance. So this is the whole table of my network properties of social difficulties. And if you observe the whole table, frequency of alcohol use, that means the regular use of alcohol has the highest values among all the other values, or as compared to all the other nodes which are available in here. It has the highest value. If you see the degree centrality, authority, closeness centrality, weighted degree, and degree. So regular drinking habit is most affected and most influential factor of the graph of the symptom of the graph of the social difficulties. So these are the graphical presentation of centrality distribution, the betweenness centrality distribution, closeness centrality distribution, how the nodes are distributed, and then harmonic closeness centrality distribution, eigenvector centrality distribution. And I prepared a second graph, which is the alcohol and mental health issues, that is the symptom network of alcohol and mental health problems. Here also we can go for the level of drinking and cluster the level of drinking into different parts or into different groups, like regularly using of alcohol once or twice per week, once or twice per month, 3 to 4 days per week, etc. And different mental problem or psychological problem like anxiety, depression, demoralization, felt guilty, etc. And if you observe my network, regular pattern of drinking is more strongly connected with different psychological problems like anxiety, depression, then demoralization and stress. And then any other notes, and if you see the other ages are somehow not so strongly connected with the notes as compared to the regular drinking habit. So
Kimasha, please conclude
yes,
within a minute. Please conclude in last 2 minutes.
okay, it contains 13 notes and 19 ages. So these are the statistics of my network. So degree centrality is obviously highest for the regular drinking habit, followed by stress and depression. And from my graph, it was observed that the highest for the regular drinking, and other than regular drinking, stress and depression is considered as the most influential factor than any other factor. So these are the closeness centrality and eigenvector centrality patterns are parallel as compared to the other centrality measures. And this is the network properties of the mental health related issues. Here we found that regular drinking habit, as the previous one, the same parallel outputs were obtained. So this is the distribution of centrality measures. So most of the researchers on alcohol use disorder focus on collection and analysis of data in terms of the criteria laid down by the nosological system ICD-10 or DSM-5. The social, occupational, physical, and other related harms have been the topic of interest in various literatures and also in various types of psychosocial interventions directed towards the ensuring abstinence. Network theory provides an unique opportunity to look into the relationship of various factors as related to drinking habit and pattern and the associated harms. So from my study, there are two major key issues we obtained. The first one is the frequency of drinking behavior is more influential than any other habits. And second one is related to the mental health problem, frequency of drinking along with its stress and feeling depressed or depression is the important components of mental health outcome in my study population. So contrary to this popular belief, it is maintained the expenses have been to the least important in causation of, has been found to be root cause of the social complications. Therapists targeted to reduce the frequency of alcohol use and management of stress and depression can be expected to be the key importance in reducing the mental health related issues. So these are my references with this. Thank you.
I request Katerina to come up with the questions.
Thank you very much, Kimasha. Your presentation was really, really good. I mean, your work is extremely interesting, and I appreciate these works. I really appreciate these works where you try to analyze the community where you live, and you try to get some insights how to use science and technology to try to improve our society and the way we live. I have a question for you because it's very interesting to see how clear in your graphs and with the measures of centrality and other features that you detected that depression, stress, anxiety was very related to the consumption of alcohol. And actually what we have seen in these last 2 years of pandemic is precisely an increase of depression, anxiety, and stress. And I would like to know if these results were collected before the pandemic started or during the pandemic, and how you think these results could be influenced by the pandemic effects.
Mm-hmm. After pandemic or before pandemic?
Yeah, did you collect this data before the pandemic or during the pandemic?
Okay, before pandemic.
Okay, that's fantastic.
Before the pandemic, during the pandemic, I stopped collecting data, and with this data, I can summarize to my network, or I can prepare my network.
That's the interesting finding, because if you have the chance to continue your study and now do it one in the context that we've been through this pandemic, I'm really sure that the graphs that you will have will even reinforce more
Yes,
all these nodes that you detected, because the stress, anxiety, depression, they have been present in many people, and a correlation between alcohol consumption, violence has already been detected in other studies. So that is very interesting. Yeah, again, I don't have many technical questions. I think the work was very well conducted. It was very well explained. So congratulations.
Thank you so much. Yes.
Thank you, Kimasha, and thank you, Katrina. I think the comparative analytical kind of work pre-pandemic and post-pandemic, the idea that you shared with Kimasha is really, helpful. I think it will give her a different angle of taking up this work and comparing it with what she has managed to do it till now. So I think Mr. Uh, I'm so sorry. Yeah. So Avalu Liti, I think you're there, and can you just sum up your work, the gist in a minute? Will you be able to conclude your research work in a minute? Avalu Liti, I hope you can hear me. Are you there? So
yeah, so we move on.
he is connected, but I'm not sure if he can hear me. So anyway, so Katerina, I would like to hear a few remarks and concluding remarks, I would say, and a few insights from today's session. We would definitely like to hear from you.
So yeah, I think the sessions today were quite interesting and as well quite diverse. So we have very technical studies like the one where we analyzed the different types of optimization algorithms in neural networks. We saw also how these technicalities in machine learning could be used in multi-agent systems. But we also had this more IoT and Internet of Things methodologies, and now we also have a really diverse set of works that incorporated human interactions in their studies, like Kimasha's work, or even Sergey's work with the hackathon, which actually I was thinking to myself, actually it should be something that one could start introducing in our research or PhD programs. Let's make a hackathon on the problems that I'm trying to solve it. Let's see what people are thinking about it. I found it a really different and interesting idea that, again, you not only provide this creativity of people brainstorming on different problems, but you also try to stimulate research interests in the community, which is very valuable if you want to show or teach science, mathematics, technology, especially to women and young girls. So I really would like to congratulate all the participants. The talks were really, really interesting and of high quality, and I wish you proceed with your work and extend it and continue to explore the world and change the world. The world is a mess, so go and make this world a better place.
Thanks a lot. Even like the kind of approach you had while going through the presentations, the kind of questions you came up with, I think we all will certainly get benefited out of it. So with that, I sincerely thank our authors for their excellent presentations in this session and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. So kindly cooperate with the team of ICICT 2022. I also thank our session chair, Katrina Moreira, for chairing the session. Just as a token of appreciation to the chair on behalf of Team ICICT 2022 and Global Knowledge Research Foundation, I would like to have this session chair's certificate of appreciation on the screen. Thank you so much, ma'am. Thank you all for your valuable presence. Dear all, I kindly request you to turn your cameras for a quick snapshot and let's freeze this moment together with our big smiles on our faces. So, which even the pandemic hasn't been able to, take away. And
Yeah.
yeah, I really wish that it stays there forever. So let's say happy, just make few happy faces and take quick snapshots. Thank you so much, everyone, for those lovely smiles and lively vibes. Stay safe and take care. With that, we are ending the session. Really appreciate the presence and active participation from everyone. Thank you so much.
Thank you.
Thank you so much.
So we are ending the session now. Take
Yes,
care
ma'am.
all.
Yes, ma'am.
Yeah. Thank you.